Hi guys, my name is Rohit Sharma, and shortly I'll talk about bringing ONNX models to microcontrollers and other IoT devices. Agenda includes challenges and opportunities of bringing ONNX model on MCUs, an open source framework for Edge compiler deepC, and applications thereof. Tiny means very small, and ML means machine learning. So for this talk, TinyML means running ML models and applications on tiny devices operating on batteries for months. TinyML refers to machine learning technologies and applications, including hardware, algorithm, and software capable of performing on-device inference at extremely low power, targeting battery-operated devices. Hardware comparison for high-performance servers with accelerators, single-board computers, and bare metal microcontrollers is noteworthy. Compute resources of MCUs running in few megahertz flops fall short in comparison to several teraflops on GPU servers. This is a whopping 6 order magnitude of difference. Similar order of differences is observed in RAM capacity and storage size of these devices. 6 or higher order of difference in flops, RAM, and storage presents significant challenges for application development on MCUs. It is noteworthy to mention that IP and MCU providers continue to improve hardware resources, while AI research community is working tirelessly to reduce the model size. As a result of these two, number of machine learning applications running on tiny devices are increasing at a rapid rate. Despite these challenges, ML applications in energy management is growing at a rapid CAGR, and video/image recognition is expected to have a largest market size in Edge by 2026. Other than growth, these applications also bring socio-economic benefits including low energy, low latency, and enhanced privacy. Initial growth in these select areas will open disruption opportunities in other industries and verticals in coming years. All TinyML apps are Edge AI apps, but not all Edge AI apps are TinyML apps. The difference is rooted in power consumption. TinyML apps typically consume less than 100 milliwatt power to be able to run on batteries. So, an image recognition application running on an edge device like a cell phone or a surveillance camera is not a TinyML application. Wake word detection like Hey Alexa or Hey Siri running in less than few milliwatts is a TinyML application. Another popular TinyML application is predictive or prescriptive maintenance based on anomaly detection in industrial sector. Power consumption typically increases with increasing performance, resulting in increased cost. So, power and cost economics tailwinds TinyML applications, with headwinds caused by performance. TinyML app development starts from gathering the data. The next two steps are typical ML development: design and train the model. The step after that is to export the ONNX model. Why ONNX? Because it is an interoperability standard. Now, one can't simply serve ONNX models on microcontrollers because of several challenges, including limited hardware resources discussed before and lack of operating system. You need a compiler that can convert ONNX format to binary format supported by MCU of your choice. The compiler must support all kinds of software development models and need to provide C, C++, assembly or WebAssembly code, static library, and executable binary with compatible linking instructions. Now, one can compile ONNX models with deepC. deepC is an open source, vendor independent deep learning library, compiler, and an inference framework designed for small form factor devices, including microcontrollers, IoT, and edge devices. It is available on GitHub with URL bit.ly/deep-c. deepC takes ONNX model as input, creates compute graph to optimize and schedule ML operations, And finally, it generates the code in embedded C, embedded C++, WebAssembly, static library, bare metal binary, and OSELF. deepC is an open source AoT compiler released under Apache license. It supports Python and allows development of custom machine learning algorithms under an inference framework. It runs in Google Colab and other popular web IDEs like cAlnvas. Check it out on GitHub with URL bit.ly/deep.c. If you are short on programming skill, effort, or time, feel free to use cAlnvas. It's a TinyML studio with no-code or low-code applications. No-code platform lets you choose, compile, and download from its App Store gallery of over 70 TinyML applications. Low-code web apps lets you customize the TinyML application to your dataset. For example, you can record your own voice dataset to train and compile wake word detection app in a matter of few minutes. TinyML Studio provides all the necessary tools to turn a dumb device to a smart one in a matter of minutes. It is free for students, researchers, and academic institutions. TinyML use case iSpeak. iSpeak is a wearable glove POC designed for mute people. It converts sign gestures into spoken words and sentences. Gestures are captured with gyroscope and accelerometers placed on fingertips integrated with MCUs. This gesture to speech technology in the hand glove is integrated with a speaker to create speech inferred with a machine learning model. Another use case is OW. OW is a backward detection, and backward detection is a task of recognizing an utterance for activating a speech assistant such as Hey Alexa for Amazon Echo. A web app for OW lets you record your own voice to create dataset for the wake word detection. It lets you train and test the application before giving you a compiled binary that can be flashed in MCU of your choice. And with that, you have a smart device that responds to your command. So that was the talk, and now I'm open to questions.